Hello everyone and welcome to Mathematics. So this video will be part 2 for this chapter, Trigo functions, and this will be all you need to know for solving Trigo equations. And again, all the examples are from this year's trial paper. Alright, so again, this is part 2 for this chapter. And in this video, we will go through the 5 tips to effectively solve this kind of questions, and also I will share the 2 main approach to solve these kind of questions. Alright, so the first thing to know, again, like the previous video, we need to be familiarized with the formulas given. Okay, so let's group these formulas into 4, square, double, plus and minus, and from the double formulas, we can form half formulas. Sorry, half group of formulas. And we need to make sure that we know this formula, tan equals to sine over cos. Right, so here we have a typical example for solving this kind of Trigo equations lah. Okay, so now let us first expand these two functions here. As you can see, inside is a plus and minus, so we can use the plus and minus group to help us expand out. And then for tan 45, as you can see here, if you you type into calculator, you will get the value of 1. Okay, so if you simplify, you get something like this. Okay, and then here to further simplify, we can cross multiply. Okay, and then we move everything to the left side. Right, reason is because the reason we need to do all this is to form a quadratic equation, as you have learned in Form 4 Chapter 2. Okay, ax squared plus bx plus c equals to 0. So here means that there's one x squared value, one is x, and one does not have x, okay, which is here. Similarly to here as well, we have one which is tan square x, one has tan x, and the other one does not have tan x. Okay, so this is a example of a quadratic function in the Trigo form, and this is our goal for all kinds of solving the equation questions. Okay, so once we reach our goal, we can use our calculator to help us factorize. Okay, so to find the two values lah. Okay, so we will find something like this, and our two values will be tan x equals to 1 over 3 and 3. Okay, so now how do we further find the value of x? So I hope you all still remember the way, which is using ASTC method. Okay, so here before we use this, I would like y'all to identify two things first. Firstly is the function. What is this function here? Second is this value positive or negative, which is really important. Okay, so now here we have tan positive. So according to the ASTC here, A here means all the functions here are positive. If let's say I go to this quadrant, if here says t, this means tan is the only function which is positive, which means s, which is sine, c, which is cos, both of them are negative. Okay, so since here is tan and positive, we will choose these two quadrants. Right, so now you all will be wondering theta. So what is this theta? Okay, this theta we calculate it from here actually. So what it should do is we just move the tan to the other side. So let me write it here. Arc tan. Okay, so this is not inverse tan, yeah. This is arc, ARC-TAN, 1 over 3. And you type this into the calculator, you will get 71.57. So this is the theta. Right? So our answers here will be, the first one is 71.57, and the other value we should 180 plus the theta that we got. So here we should get 251.57. Okay, so same goes to tan x equals to 3. Same thing as well. Tan positive, so we should look at this and this. Right, so here we should we should find the theta first. So theta is, if we move tan to the other side, arc tan 3. Okay, type this into the calculator and you will get 18.43 here and 198.43 if we plus this value with 180. Okay, so we have 4 kinds of answers, so let's combine them into one. Alright, so make sure to do this as a conclusion that this is your answer. Right, so you'll be wondering why we should use the ASTC method. Okay, so imagine we don't have this. If we use the graph method to help us find. So this means, right, if let's say, if we go back to this one, tan x equals to 1 over 3, and we let tan x as y. So we are finding the values of x where y is 1 over 3. So it may be something like this. And then we need to find the values here that touches the graph. So we need to find the 2 values of x here, which is actually this 2. But this will be much harder, much not so straightforward compared to this one, because we need to use the graph to help us find. So to save all of this trouble, we can just use the ASTC method to help us find the values of x. Alright, another extra question, which is what if, let me write at the bottom here. Right, so what if the tan here is negative? What should we do? Right, from the whole process, we just need to change one thing, which is the which quadrant should we choose. Okay, so just now it was positive, so we should choose A and T, but now it is negative, so we would choose S and C, because these are the 2 areas that T or tan is negative. Okay, so again, this one we should calculate our theta first, but this one, there's a common error in students whereby they would write the negative inside the calculator. Alright, so please don't do this. Don't put the negative inside, just put the value. Alright, so the theta, if you put inside the calculator, you will get this value which is 71.57. Okay, so your answers would be different automatically, which is 180 minus theta and 360 minus theta. Okay, and this will be your answer. Right, so let's go through some more examples. From Johor, we have this equation, and if you can see the equation, right, there is 2 different functions, cos and sine. Okay, unlike our previous example, we have only tan. So the question is, should we change cos to sine or sine to cos? Right, so I would suggest don't focus on the function itself, focus on the things inside the function. We have 2 theta for cos, theta for sine. So our approach is we should change functions that have 2 theta or square to the ones that have theta only. So this means we should change cos to sine. So this is our goal, to help us form the final goal, which is this. Okay, so let's use the double group of formulas to help us find. Right, so this one, since we are changing from cos to sine, so let's just use the formulas that have sine only, which is this and this. Okay, but I wouldn't suggest to use this one because there will be another cos. What we want to do is to eliminate the cos. We don't want another one to come out, right? So we would just directly use this one, 1 minus 2 sine square x, 2 theta for this question. Okay, so then you can see that the equation here is all sine. Okay, and then we can further simplify. So this is our goal. Okay, our goal. And then we use calculator to factorize. Okay, so now we have 2 different values. Sin theta equals to 2 and negative 2 over 3. So we can use the ASTC method to help us. But this is the second tip. For sine and cos, we only accept values from negative 1 to 1. This one is 2. So here we should reject this. Okay, why? If you look at the sine or cos graph, so let's say if I use sine, the maximum value that we get is 1 only. Minimum is negative 1. So if they want 2, this means I need to find a value here. And this line does not intersect the graph. So it's impossible to find value of theta here. Okay, so for this one, we should reject straight away. So we will only accept values from -1 to 1 for sine and cos only. If you look at the previous question, tan is already exceeded the value, but tan we have, because for tan the graph is infinity. It has a value at 3. Okay? And for this one, we should use the ASTC method lah. Okay, so for this one is sine and the value is negative, so it should be T and C. Okay, T and C here should be 180 plus theta and 360 minus theta. So if you type this into your calculator, again don't type the negative inside, you should get 41.81 degree. Okay, so by substituting theta into here, you will get these two values. Okay, so there's another tip I'd like to share, which is check the range and the unit for this part. Okay, as you can see, it doesn't start from 0, so sometimes it might limit your range. Okay, so this one we are quite lucky because 180 and these two values are actually more than 180 within 360. Okay, so we are safe, don't have to change anything. And sometimes the unit might change, so sometimes here theta, it not be the degree format, sometimes it will be 0, theta, 2 pi. So for this kind of cases, we need to change our answers to radian. Right, more examples. From Kelantan, we have this equation. As you can see here, we have cos and sine at the same time. So again, for those functions which have 2 theta or square, we should change it to the ones that have theta. So cos should change it to sine. Okay, so similar to our previous example, we should change the cos 2x to become the last equation, 1 minus 2 sine square x. Okay, and then we have reached our goal to form the quadratic equation. Okay, and then by factorizing, you will get these two values. Right, so this kind of value, which is one we need to take note. So this is the fourth tip I like to share. So for sine and cos, and with special values -1, 0, and 1, we should draw the graph out to find the answers. Okay, so for the sine, we should find the parts that have the value 1. Okay, so as we know, the maximum value is 1 here, so this should be our answer. So this one is 90 lah, 90 degree. Okay, so our answer here should be 90 degree. Right, reason why we need to draw the graph is because there may be multiple answers. Okay, so this one is quite lucky because we only have 1. But if there is multiple answers, the calculator might not catch it. Okay, calculator might maybe give you 1 answer, but technically there are maybe three answers. Okay, so make sure for these special values, -1, 0, and 1, we draw the graph out. Okay, so an example lah, for multiple answer questions. Let's say sine x equals to 0. So if it's 0, you can see that here we have 3 answers. So here should be 0, 180, 360 degrees. Okay, 3 answers which the calculator could not catch. Okay, and for this one, okay, so this one we can use the ASTC method, and here we should use, the quadrant we should use is T and C. Okay, and our theta here, it should be 6104. So here T we should add 180, C we should 360 minus the theta. And for the next example, I would like you to try out first. Okay, so I'll pause a few seconds to let you all try out. And for this one, part 1, we have already proved from the previous video. So y'all can just straight jump into the second part. Okay, so for our current equation here, we can substitute the one in part A1. Okay, and then because the denominator has sine x, so I'll multiply the whole equation with sine x, and we will look something like this. So for the functions here, you can see that sine, there's a square here. Okay, so again, our approach is for those that have 2 theta or 2 will become, we need to change the function to become the one that has theta. So here, sine should change to cos. Okay, so one of the equations that I can use would be this one. Okay, so this one, if I move cos A to the right side, it will look something like this. Okay, so this is this part. Okay, and you may be wondering, there's actually a lot of formulas to change sine square x. For example, this one. But why I didn't use this? Okay, reason is because if I use this one, right, after I change, it will be something like 1 minus cos 2a. I would like to eliminate those 2 or square. So if I use this one, I will still get back the same problem, which is I still have 2a here. Okay, so I wouldn't use this one, but I'll use this one because if you see if I change right, the x still remains x. But my sine becomes cos, which is what I want. Okay, so this one we further simplify. This is our quadratic equation, and we factorize, and we will get these two answers. Okay, so again, for cos x equals to 1, so this is a special value, so we need to sketch the graph out. Okay, so there's not much space here, so let me draw here. Okay, and cos graph is something like this. So for the value of 1, we have 2 values. Okay, the start and the ending point. So our x here is 0 and 360 degrees. Okay, and for this one, so again, for the tip that I shared just now, this one we should reject because it's not within -1 to 1. Okay, and here, let's check the range here. Okay, the range here, 0 to pi. So this one, we need to change it to the radian format. Okay, so for this one, we couldn't give our answer like this. We need to change it to radian form, which is 0. 360 means in the radian form is 2 pi. Okay, so this would be our answer. So this one, I use the formula, multiply pi over 180 degrees. Next example from SPP. For this equation, we have 2 functions, cotangent and cosecant. Okay, so for this one, we can solve it in 2 ways. One, because here we have, both of them have square. So what we can do is we can go to the square group of formulas and to see whether is there a formula that has these 2 functions. Okay, second one would be I would change the cotangent and cosecant to become sine or cos, so maybe it will help us find the value of theta here. Okay, so for this one, if we go to the square group of formulas, luckily there is one, which is cosecant and cotangent in the same formula. Okay, so here we can either choose to change cotangent or cosecant, either one. Right, so for this one, I will choose this one, cosecant square theta. So I will change it to 1 plus cotangent square theta, which is here. Okay, so once I simplify, I will get something like this. So this one would be not that similar compared to our previous examples. Our previous examples, we want to find this goal, right? This is our goal, to change it to the quadratic equation format. But this one does not look like a quadratic equation. It's okay. Okay, it's okay, because the goal, after the goal, we want to find the function's value. So this is the same as well. Cotangent square theta cos x, and then equal to something. Okay, it's the same. So if I move the 3 to the right side, it will become 1. Okay, and if I move the square to the other side, it would be something like this. But again, if we move the square to the other side, we need to have plus and minus at the same time, correct? So here we do have 2 values, plus and minus. So this one, cotangent, we are not really familiar, so we will change it to the tan first, 1 over tan theta. and I want to change it to become tan theta only without the 1 over above. So I would like to change the places. Okay, so if I change here means the right side I also have to change, right? Okay, so this one would be something like this lah, plus minus 1 over 1. But here the funny thing is, if I change, it does not make any difference, right? Because both of them is 1 and 1. Okay, so this one I will just maintain the right side. And now we have two values here, so I will split. Okay, so this one, the special value 1 and negative 1, this does not apply for tan, yeah? Like for example, in the fourth tip here, only sine and cos, right? So make sure you have know that tan does not apply for this tip. So the method to help us solve this one would be the ASTC method. So this one, if I move the tan to the right side to find my theta would be 45, and here tan and it's positive, so it's A and T, which would be these two values. For the right side, this one, the only difference is this is negative. The value is the same, so we don't have to recalculate the theta. Okay, so this one I will just choose the quadrant that we want. So this is tan negative, so it should be S and C. Okay, and our values will be something like this, and then we need to combine all the answers that we have obtained. More examples we have from Negeri Sembilan, and our equation here we have sine square x and cos x. This one technically is not a function because the value is given. Okay, so again this one we have square, so this means we need to change from sine to cos. Okay, so for this one I would use the similar approach with the Terengganu question, which is to use this formula to help us change to become cos. Okay, so this one you'll change it, we'll move it to the right side, and we will get from sine square x to become this 1 minus cos square x. Okay, and then we move everything to the left. Okay, so this one technically it doesn't look like a quadratic equation because it is missing this part, the C part. Okay, so maybe what I can do is maybe factorize the cos x, and then maybe I can move it to the right side. Okay, so I will only have this left, 1 minus cos x, and then I will get cos x equals to 1. Okay, so this approach is actually wrong, yeah? This is wrong. This is a very common mistake in students when solving this kind of questions. Okay, this one means, so this is my last tip, which is do not eliminate or do not move anything to the right. Okay, actually this one is our goal. It's already our goal. Reason is because if you go back to the previous examples, right? Yeah, this one. It's actually the exact same thing. It's just that there's no negative 1 here. Right? It's actually the same thing. So what we should do is to stop at here. Stop at here. Don't move it. Don't move the cos x to the other side. And we split. Cos x equals to 0 and 1 minus cos x equals to 0, which is this one lah. Cos x equals to 1. Okay? So now these two values we have now is all the special values 0 and 1, and the function is cos, so we need to use the graph method. Okay, so for 0 it will be these two values, 0 would be these two values, 1 would be these two values. Oops, sorry for the mistake. Okay, so our answers would be 90 and 270 degrees, 0 and 360 degrees. Okay, so we need to combine them together, and again look at the range. We have 0 to 2 pi, so this one need to be in radian format. So all the values here we need to multiply pi over 180, and technically this 0 we shouldn't have pi. Okay, so this would be the final answer. Alright, we have another set of examples, but we use a different approach compared to the previous ones. Okay, so if you look here, now now we change from theta to 2 theta or square. Right, so for now, if we want to use this approach, I only saw one case only, okay, which is this one. Sine 2 theta equals to 2 sine theta cos theta, correct? So now the question is like, I give you this one, change it back to sine 2 theta. Okay, so if we look at the Kedah's question, you can see that the equation has cos and sine together. Again, this is like the formula here. We have sine and cos together. So this one we can change it to sine 2 theta if we move the 2 to the left side. Okay, so this one will become sine 2x equals to 1. Right, so this one is a special case. This is 1, so our answer would be, this is 1, so answer is 90 degrees. Okay, but this one is 2x. Previous questions we saw is only x. So is there a difference when you are finding answers? Yes, there is actually. Okay, so let me explain what is x first. So x means we only go one cycle. Okay, and let's say if I draw a line here, I want to find the intersection points. So we will only have one. Okay, so if it's 2x, means I need to do another cycle. And you can see that for the line we have, now it intersects 2 points, which means we need to have 2 answers. So if x has only one answer, 2x, we need to have 2 answers. Okay, so how to find the other answer? Very easy actually, because we are going to another cycle. Another cycle means another 360 degrees, right? So for the other answer, we just need to add 360 to get the second answer. Okay, and then I can just move the 2 to the other side, and I have found my answers. But you have to check the range here, because here it says on error 80 to 360, so 45 we need to reject. So the only answer would be 225. Okay, so we can write out another final statement, something like this. And for the next one is from Perlis. For part A, we don't have to do this because the previous video we have already proved. Okay, so let's jump to the second part, which is to solve the equation. So we have this one, and if you compare to part A, it's very similar. It's just that the 2 is not there. Okay, so what we do is we just multiply the 2 first. Okay, and then we change this with the result here, sine 2x. Okay, so now let's solve this one. So this is not a special case anymore, so we need to use the ASTC method lah. Okay, so this is sine positive. Quadrants would be A and S. And here, this is what we should do when we have the theta. Okay, so theta here, we need to move the sine to the other side. So arc sine 1 over 2, it will become 30. Okay, so our answers would be, our answers would be these 4 values. Okay, so let me explain. Yeah, so the theta just now we found is 30, so this is here 180 minus theta, which is 30, so it will be 150. Okay, and then where does this 390 come from? This one is because we are going to another cycle, right? So here we need to add another 360. 150 here, same thing as well. We need to add another 360. Okay, so this means that if x we have 2 answers, means 2x we do need to have 4. If let's say 3x, this means we do have 6 answers. Okay, and so on. Right? So the 2 I need to divide for all these values, so it becomes something like this. Sorry again. Okay, so this is our values, and again if we go back to the range, we have 0 to 2 pi. So again, this is radian format, so we need to change everything to the radian form. So multiply pi, divide by 180. Okay, and this would be our answers. So now I would like you all to try out this question from Sabah. So I'll pause a few seconds to let you all try out. Alright, so the answer is this one. Okay, these 4 answers, and then I'll explain how do we get this up. Okay, so for the equation here, we have sine and secant. So what I will do is just change the secant to cos first lah. Okay, so it'll be 1 over cos theta, and then I will move it to the right side, sorry, left side. The 4, I will move it to the right side. Function with function, number with number. Okay, so now again, this one, we have sine theta, cos theta. We have only one formula that combines these two, which is this one, right? So that this one we have don't have the 2 here, so that's why I multiply 2. Okay, and then this one I can change it to sine 2 theta, and the right side we have square root 2 over 2. So this one same approach as well, using the ASTC method. This is sine positive, so it will be here. Here we do 180 minus theta and theta. So the theta here is 45, right? So this is my first value, sorry, my first answer. Use 180 minus theta, you'll get 135. And then since this is 2 theta, so means another cycle, right? So another cycle means I need to add 360 here, 360 here to get the third and the fourth answer. Alright, and then the 2 I can divide all of the values. Okay, and this is how you get the answer. So here's a summary of this video. So firstly, familiarize yourself with the formulas given. So the 4 groups, again, we have the square group, the double group, the plus and minus group, and the half group. Right, now we know that we have 2 approaches to help us solve the equations. Okay, so one is for the functions that have 2 theta and square, we will change it to the ones that have theta. And for the second approach, this only, I would say, only applies for the 2 sine theta cos theta, change it to sine 2 theta formula. Okay, because this one is the other way around, theta to become 2 theta. And the second tip here is for sine and cos, only accept values from -1 to 1. Again, for the maximum and minimum value for these 2 graphs is only -1 to 1. Okay, that's why we accept within this range only. Okay, third one, check the range and the unit. Okay, fourth one, for sine and cos with special values like -1, 0, and 1, do draw the graph because there may be multiple values, sorry, multiple answers. And the fifth one is, I think this is very important, do not eliminate, do not move certain functions to the other side to make it disappear. Alright, so that's the end of this video. So I hope this video has helped you to maybe learn something new and also help you to revise some certain concepts for this chapter. Okay, and then if you all have any questions regarding this video, feel free to comment below. So if you all feel this video is beneficial to you, again, you all can subscribe, like, and share the video to your friends and classmates. Okay, so for the next video, we'll go to part 3 and I'll see you all there. Okay, bye bye.